In this video tutorial, we will learn how we can track each of the detected objects using DeepSORT object tracking algorithm. We will be integrating YOLOv9 with DeepSORT object tracking algorithm. So we will use YOLOv9 to detect objects in image, video, or in a live webcam feed. And then we will be using DeepSORT object tracking algorithm to track each of the detected object until that object remains in the frame of a video or in a live webcam feed. So what we do in object tracking? In object tracking, we basically assign a unique ID to each of the detected object, and then using that unique ID, we track that object until that object remains in the frame of a video or in a live webcam feed. So using that unique ID that we assign to each of the detected object, we then track the object. We can also draw trails to follow the path, to check the path the object is following. So that's all we are going to learn in this tutorial. We will be integrating YOLOv9 with DeepSORT object tracking algorithm. You all know YOLOv9 was released last month on 21st February 2024, which is the state-of-the-art object track detection algorithm. And YOLOv9 outperforms all the previous object detection algorithms as well. While DeepSORT algorithm is the state-of-the-art object tracking algorithm. So by combining the state-of-the-art object track detection algorithm with object tracking algorithm, we will be doing object detection plus object tracking. So that's what we are going to learn in this tutorial. Plus, we will also see if the object gets blurred or hidden. We will also be tracking that object, and that object unique ID will remain the same. Okay, so let's get started. So over here, you can see in PyCharm, I have opened PyCharm over here, and I have Python 3.10 installed. You can see over here. Plus, I have just created a project over here by the name YOLOv9 DeepSORT OT. So I've created this project in my app directory. So in the same way, you can create this any project in any of your directory. Plus, you can also use Visual Studio. I'm using PyCharm. You can also use Visual Studio as well. So in the first step, we will go step by step. So if you just see this node file, I have written all the steps to which I will be following. So first we need to clone the YOLOv9 repo. So I will just open the browser over here. And I will just go over here and I will just write YOLOv9 GitHub over here. So YOLOv9 GitHub. So I will just search for this YOLOv9 GitHub over here. And I will just open this first link from here. Okay. So this is the YOLOv9 official GitHub repo. It has around 7,000 stars. So I will just clone this complete repo into my PyCharm directory. So I will just copy this link from here. Then I will just go to the PyCharm over here. And then I will just go here. And then I will just write git clone. And here I will just add the repo link. So now it will clone this complete repo into my local directory over here. And you will find this. Okay, so it's done now. So if I just refresh this, so you can find this complete YOLOv9 repo over here. So now in the step number 2, I will just set this YOLOv9 repo, which I have cloned as my current directory. So I will write cd YOLOv9 over here. So now this is being set as my current directory. So now if I just open the requirements.txt file, the requirements.txt file you can find, they have listed all the required packages that are required to run the YOLOv9 repo successfully. Okay. So I will just, as we will be integrating object tracking using DeepSORT algorithm, so we need to add few more packages as well. So which is index, you can add it, and plus I will see if the NumPy is packages over here. So okay, so we require NumPy package less than 1.24. Else we will be getting an error, so it's always better to do this. And we also require gdown package because we will be installing demo videos or DeepSORT files from the drive directly into this PyCharm ID. Okay, so now in the step number 2, what is install all the required packages. Okay, so we will be installing all the required packages over here. Well, now to install all these required packages, I will simply write over here pip install -r requirements.txt. So we don't need to install all these packages one by one. If we just write requirements.txt pip install, it will install all the packages that are listed in this requirements.txt file, and I will now click on enter. So now all these packages will be get installed over here. So this will take some time for all these packages to get installed. So let's wait for these packages to get installed and then we will go ahead. Now you can see that the packages are installed. So now in the step number 3, what we need to do is we need to download a DeepSORT files. So I will just copy this link from here. Just copy this from, okay, and I will just paste this link over here and I just click on enter. So this will download the DeepSORT files from the drive into this Google Colab notebook or into this PyCharm ID. So I've already placed this DeepSORT zip file into my drive, and I'm directly downloading the DeepSORT py.zip file from my drive into this PyCharm ID. So now we just need to unzip these DeepSORT files. So what I will do for this, I will just click over here and create a new script.py file. In the script.py file, I will just write some code to unzip these DeepSORT files. So over here, import, I will just write over here, import zip file with zip file dot zip file. Here I will just write the name, which is deepsortpy.zip. So we need to read this as zip dash ref, and we need to extract for this complete file. So just do this, and over here I will just run this file. And let's see how does it works. Okay, so do we have the, okay, so now you can see I've just I completely unzipped this file over here. Okay, so there is a function in Python unzip, but that function does not work in PyCharm. I have tried that function in Google Colab. It works fine there, but that doesn't work in PyCharm. So in the DeepSORT PyTorch, if we I have now unzipped it, so you can see here we have a DeepSORT folder where we have the complete deepsort.py file code as well, and we have the configuration and README file over here as well. So this is what we all require. Okay. Next, what we need to do is we need to download a demo video from here. So I've already added the link over here. So okay, so then we are just good as well. So now in the terminal, I will just add the link over here. So this will download a demo video from a drive into this PyCharm ID over here. Okay, so now you can see we have the demo video over here as well. So if I just retrieve, okay, so no need to. So you can see here testbox.mp4. We have this demo video over here as well, on which we will be doing detection and tracking. Okay. So in next, what I will do is so in the detect-dual.py, we have all the object detection code. So I will just add another file, detect-dual.tracking.py, in which we will be doing object detection plus tracking over here. So over here, you can see that I have added detect-dual-tracking.py file. So here I will be adding the DeepSORT code. I have added some DeepSORT code over here, which include initialization of DeepSORT algorithm. So over here, what I have done for now is I have initialized or I have imported all the DeepSORT required packages over here, which you can see over here. And then I have initialized DeepSORT over here. I have initialized a DeepSORT tracker over here. and all the parameters which you can find over here. So the important parameter which you should need to know, I have written all the comments about each of the parameter above. You can read that as well. So here is the maximum age parameter. So you should need to know about that parameter. So in the maximum age, what we define is that, for example, due to an illusion, or if for any in any case, if an object tracking ID is lost for an object, um, so in the maximum age, we define how many frames it should wait to get that ID back. So, for example, if there is a car and we have lost that car object tracking ID due to an illusion, so how many frames that it should wait for it to get back, or if it doesn't get back in much frames, then it will assign a new ID. So for example, if I set the maximum age value to 20, so it will wait 20 frames to get the object tracking ID back. And if in 20 frames, it does not get the object tracking ID back for that specific object, it will assign that object a new ID. So if you can see over here, if an object tracking ID is lost, this parameter determines how many frames the tracker should wait before assigning a new ID. So you can see all the details over I have written over here. Then over here, I have defined the minimum confidence, maximum distance, NMS, maximum overlap, maximum IOU distance. So you can read all those commands. I defined every parameter over here. This will take quite some time, so I will skip this. And here I've just created the function initialize deep sort. So I have just initialized that over here. Okay, and here because our YOLO V9 model has been trained on the COCO dataset, so the COCO dataset consists of 80 different classes. So I've written all those 80 different classes names over here. And then, for example, here I've defined the color label. So if we have the class, if in a video frame or in a live webcam feed, person is detected, then we have assigned, if the person is detected in a live webcam feed or in a video, then the bounding boxes will have the following color. So if the car is detected, then the bounding boxes will have the following color. If the motorbike is detected in a video frame image or in a live webcam feed, then the bounding boxes will have the following color. And if the bus is detected in a video frame or in a live webcam feed, then the bounding boxes will have this color. Okay. And over here, there we have loaded the model. We have applied non-max expression over here. So this is all what is going over here. So from now where I will just add the object tracking code. Let me show you. So from here, I will start adding the object tracking code over here. But before I add this, so you can see over here. Okay, so in the YOLOv9, we get the output in this form. Like you can see that the YOLOv9 object detection algorithm returns the output in this form. We have the bounding box coordinates. We have the uh, top left corner bounding box coordinate. You can see this is the top left corner and this is the bottom right corner. So the YOLOv9 model outputs return the top left corner bounding box coordinate and the bottom right corner bounding box coordinates. So this is what YOLOv9 returns. Top left corner bounding box coordinates and the bottom right corner bounding box coordinates. So we need to pass the YOLOv9 object detection algorithm output to the DeepSORT algorithm. So the DeepSORT object tracking algorithm accepts the input in the form of width, height of the bounding box. So this is the width. Okay, here I'm wrong. This is the height. So this is wrong. If I just correct this up over here. Okay, so this is, so let me just correct this. So this is basically the height and this is the width of the bounding box. So the deep sort object tracking algorithm accepts input in the form of height, width of the bounding box, and the center coordinates of the bounding box. So these are the four parameters that are required that we should pass in the input of the deep sort object tracking algorithm is the center coordinates of the bounding boxes and the width and the height of the bounding boxes. So from the YOLOv9 object detection algorithm, we get the top left corner bounding box coordinates and the bottom right corner bounding box coordinates. So this is what we get from the YOLOv9 output. So we need to transform that output into the height and width of the bounding boxes and the center coordinates of the bounding boxes. So first we need to do this. We need to transform the YOLOv9 output into this height, width, and the center coordinates of the bounding boxes. So over here, I will start writing the code. So from YOLOv9, we get that top left corner bounding box coordinate and the bottom right corner bounding box coordinates, which we are here. Plus, we also get the confidence score and the class names. So these are the output we get from the YOLOv9. So here, if you just write, so x1, y1 represents the top left corner and x2, y2 represents the bottom right corner bounding box coordinates. So the output is in the form of tensors. We need to convert the output into integers first. So I will just write over here int x1, int y1, int x2, and int y2. So we need to have transformed the output from tensors into integers. So now we will find the center coordinates for each of the detected object. So as I told you that in DeepSORT algorithm, we need to pass the input in the form of center coordinates for each of the bounding box of the detected object and the width and height of the bounding boxes. Okay. So we will find the center coordinates first, and then we'll find the width and the height of the bounding boxes as well. So I will just write over here. So here I will just find the width, height of the bounding. So to find the width, so you can say that basically we have x1. Okay, so if I just write over here, we have x1, and here we have x2. So if we subtract x1 from x2, we get the width, and if we subtract y1 from y2, we get the height. So I will just write over here x1 minus x2. So this will give me the width, and for the height, I will just write over here. So the deep sort algorithm accept input in the form of center coordinates and width and the height of the bounding box. So we write over here width. Okay. So now we need to append all these width and how, because in a frame there will be multiple objects that will be detected. And so we have center coordinates for their multiple objects and width and height values for multiple objects that are detected in a video frame, in image, or in live webcam feed. So I will just here append. Okay. Then I will also append all the confidence values over here as well. Plus, we have also have these class IDs as well. For example, the class ID for the person class is 0. So, but these values in the form of tensors. So we need to transform those values from tensors into integers as well. And I will append these values over here. And okay, so that's done. Then we have, so now we need to convert these values into tensors again. And as I told you that a deep sort algorithm accept input in the form of uh, deep sort algorithm, object tracking algorithm accepts input in the form of center coordinates and width and height of the bounding boxes and along with the confidence score and the class names. Confidence score and the class IDs. We don't have the class names yet. So, so as we have transformed our output in the form of tensors and then we have confidence score over here as well. So here we have the class IDs and is IMS represents the current frame in which we will be doing this. So if we have detections, like if we have some I detections or then we will be doing the tracking as well. So, so now you can see over here, in the deep sort object tracking algorithm out input, we have passed the center coordinates, width and height of the bounding boxes, and the confidence score, and the class IDs, and the current frame. So the what output we get from the deep sort algorithm. So here in the deep sort algorithm, so if I just write over here, deep sort algorithm output. So so this is what we get if I just again zoom it up further. Okay, so here we can. So in the deep sort algorithm output, we get the bounding top right. Uh, no, this is a top left corner bounding box coordinate and the bottom right bounding box coordinate. So deep sort algorithm output returns the top left corner bounding box coordinate and the bottom right corner bounding box coordinates, which you can find over here. So we get the bounding box coordinates in the deep sort algorithm output, a unique ID for each of the detected object, plus the deep sort algorithm also return the class ID. For example, for the person class, it's 0. So there are three things that we get from the deep sort algorithm output. One is the bounding box coordinates. The second thing is the unique ID for each of the detected object. This is what we do in object tracking. In object tracking, we assign a unique ID to each of the detected object. And we also get the class ID for each of the class. For example, for person class, the class ID will be 0. So in the bounding box coordinate, we get the top left corner bounding box coordinates and the bottom right corner bounding box coordinates. Okay. So first, I will write over here. First, we get the bounding box coordinate. We get the top left corner bounding box coordinates and the bottom right corner bounding box coordinates. Plus, we get the IDs for unique IDs for each of the detected object. Plus, we also get the object ID. For example, for the person class, the object ID is 0, and for the car class, it's 1 or 2. Okay. So now we need to draw those bounding boxes around each of the directed object, and we need to add the ID for this as well. So I will be creating a function by the name draw dash boxes, and in the draw dash boxes, I will be writing the code so that I can draw bounding boxes around each of the detected object, assign a unique ID for each of the object, and write the class name above each of the detected object. So in the input, I will pass in the bounding box coordinates. Uh, then I will be drawing the trails. So to see what path the object is following. So to track the path, then I will be passing a unique ID for each of the related object in the input, and object ID, which is the class ID as well. So object ID is basically the class ID, like for the person class is 0. So these will be all the inputs. So let's write the draw dash boxes function. Okay, so we can just narrow down this. So here I will be writing down the code for the function draw dash boxes. The input will be the frame, the bounding box coordinates, draw trail so that we can track the path, the identities. So we can initially set these values to none over here. Then we have the categories as well. So we can set this as none as well. So categories are basically the class IDs. Then we have the offset. We can set this to 0. So let's write down the code, complete code over here. So let's find out the height and width of the current frame. Okay. Then I will write, okay, for I comma box. So now we will loop through each of the bounding box coordinates. Okay. So now I am looping through each of the bounding box coordinates over here. So in the bounding box coordinates, let's add some offset value over here. Okay. So here we have defined the offset value over here. So now we are looking through each of all the bounding boxes, and here we are just getting the coordinates values for each of the bounding boxes. So we are looking through each of the bounding box coordinate one by one. So now we can find the center point of the bounding box. So find the center point. Uh, so here we are just finding the center point of the bounding box. Then over here, we are calculating the class IDs for each of the directed object. Then using the class IDs, for example, if there is a person, then we will have the bounding boxes will have this color. So we will simply write over here And here we will pass the class ID. Then for each of the detected object, we will have a unique ID for each of the detected object so that we can track that object using that ID. So in the identities, we have the unique ID for each of the detected object. So, so now we will just draw a rectangle around each of the detected object, or you can simply say we are drawing bounding boxes around each of the detected objects. And the thickness of the bounding boxes will be 2. So now what we will doing is that we will be using that ID. So if the ID is 0, then there will be person class. If the ID is 1, then bicycle. If the ID 2 is, then it belongs to the car class. So, so in the category, we have the ID for each of the class. And using that ID, we'll find the class name. So in the label, what we will display is that first I will display the ID. Then we have the class name over there as well. So two things will we have in our above the bounding boxes where we will display the ID, unique ID, and then we have the class name. We will not be displaying the confidence score over there. So now we will be finding the text size. So we want to keep the font as 0.5. So now we will be creating a rectangle above the bounding boxes as well. And we want the rectangle to be filled, so we'll just write -1. And then we will be adding the text in the rectangle which we have created above the bounding box. In the text, we will be displaying the label which contains the class name and the with ID, unique ID of the object. Just setting the location of that label. And the color will be white for the text. And the thickness of the text will be 1. So now we will be creating a circle at the center of each of the object. Okay, so now we have done this code. Plus, we also want to draw the trails over here as well. So we can track the path the object is following. So I will just write down the code for this over here as well. Okay. If ID not in data DQ. So data DQ is a type of dictionary that we have initialized above, and it has a maximum length of 64. Okay, so now we'll just write over here if draw trails. So if the user wants to draw the trails for I in range is none. So now we'll just calculate the thickness over here. So we need to initialize the NumPy package at the start over here as well. So I will just write import NumPy as NP. Okay. Okay, so we have already imported this, so no need to. I thought that not imported. So we need to multiply this by zero point 0.5 over here, or we can make it 1.5. Next, we need to draw the trails. So to draw the trails, we will using cv2.line so that we can draw trails. The input will be frame. One. And here we have data DQ ID 1. Then we have the color and the thickness as our input as well. And so that's quite fine for now. I think I've written all this. So let me execute this script file and show you how our output looks like. Before I run this, I forgot that I have not downloaded the model weights. So I will just go over here and just click over here and the model weights will start downloading. So if I just go over here, let me just close these files. Okay. So I should have over here the model weight saved. So if I just check over here, okay. So let's wait for this model weights to get download. So it will take few more seconds for this model weights to get download. Okay. Okay, so they are about to complete. Okay, so that's done. Okay, so let me just add over here. So I will just add there over here. Now you can see it So let me just run this now in the PyCharm. So let me just run the script and show you how our output looks like. So now to run this up over here, we just need to write this Python detect dash dual dash tracking.py. Here I will just define the weights file, which we have downloaded, and that's my input video. And I'm just running it on CPU because I don't have GPU in my local computer. So CPU and dash VO image so that it can show me the output image or output in the, it will open a window where I can see the output video over here as well. And my output will be saved into this. Folder as well. So let's run this up now. Okay, no such file folder. Okay, so I think mistake is on my side. Let me. So we need to set the YOLOv9 folder as current directory. So now let's run this up. Okay, so this will take few seconds before it start executing over here. So here we have the model summary, gradient 0, parameters. So the parameters are in millions. Okay, so you can see the output. Currently, there are no detections, but let's see as we go ahead in the frames. Do we have any detection or not? Okay, so now you can see here we have the detections, and you can see over here a unique ID is being assigned to each of the person. Look, so here we have the person. Like you can see over here, the 19 is for unique IDs for this person, 2 unique IDs for this person, 28 unique IDs for this person, which disappears. 5 unique IDs for this person, 17 unique IDs for this person, 15 unique IDs for this person. And here we have detected the handbag. So the 30 unique ID is for this person, the 14 unique ID is for this person, 12 unique IDs for this person, 11 unique IDs for this person, 9 unique IDs for this person, the 8 unique IDs for this person, 16 unique IDs for this person, 21 unique IDs for this person. So each of the person is being assigned a unique ID over here. Okay, so if you want to draw the trails, and plus you can see we have detected a handbag and we have assigned ID 30. So as well, so if you want to draw the trails, you can just write over here dash dash draw dash trails. And if you want to select any specific class, like if you don't want to detect handbags in the video, you can just write classes 0. So 0 is for the person class. So if you want to know more about the class, so you can see 0 is for the person class, 1 is for the bicycle class, 2 is for the car class, 3 is for the motorbike class. So here I have listed 80 different classes. So it start from 0 and end at 79. Okay. So I want here in the classes, you will assign the ID for which specific class you want to detect. So if you want to detect all the classes, you can skip the classes over here. But if you want to detect specific class, you can just pass out the ID of that specific class or multiple classes. You can also create a list and pass the ID of the multiple classes that you want to detect. So now it will not be detecting handbags or any other things. It will only be detecting the person class because we have passed the ID classes as 0 and we have draw trails. So it will be drawing the trails over here as well. So let's see. Currently, there are no detections. After a few frames, initial frames, we start to see detections usually. Okay. So now you can see over here, we have the detections. Okay. Okay, so now you can see the red center as well. So these are the trails which will not be drawn. So now you can see as the persons go ahead, the trails increase as well. So you can see over here, it's a bit slow, but now you can see the trails is also increasing. So we're just tracking the path that the person is following. You can also do is for other classes like car, you can track the path the car is going on and so on. So now you can see I am drawing the trails over here as well. We have assigned a unique ID using object tracking algorithm. We are also tracking the path the person is following over here as well. Okay. So this is all we have done in this code. We are using object tracking algorithm. We are tracking each of the detected object and we are drawing the trails over here. So using trails, we are tracking the path, like you can see. So this trail's length will increase as the person goes ahead. You can see over here. These are the trails that we have drawn, and this trail length will increase as the person goes ahead further as well. Okay. So now you can see over here. So I have run this script on the Google Colab free GPU as well. So that I can use the GPU and show you how fast it works. So I have the demo video over here with me as well. So let me just play that demo video. So I have run this script on GPU, so you can see the processing comes very fast, and we have it offers good frame rate at on GPU. So you can see we have a good number of detections as well, and the speed is very good as well. So let me show you the output video over here. So now you can see over here we are able to detect the person. We have assigned a unique ID to each of the person as well. Plus, I'm not drawing the trails. You can draw the trails if you want as well, so that you can track the path the person is following or any other object. So in this tutorial, we have learned how we can track each of the detected object by assigning a unique ID to each of the detected object. So in this tutorial, we have integrated YOLOv9 with DeepSORT object tracking algorithm, and we have tracked and detect each of the object as well, and we have assigned a unique ID to each of the object. Plus, we have also drawn trails to track the path the object is following. So that's all from this tutorial. Thank you for watching.